Okay, let's see. So you just have one today. First one says to write the following as a fraction with one sign. So it's just a review of signs in a fraction. So first of all, what's the sign going to be of this fraction? It's going to be negative, right? Is that confusing to anybody? Okay. So I can't reduce 15 over 43. So where do I put my negative? Out front, right? That means the fraction is negative. Correct? So I certainly, if it was just like this, I still can't leave it like that, can I? No. You need to pull the sign out front like that. So which one of these is not equivalent to 5 over 13? Not equivalent to it. D? Is that what you said? Or C? Like D? That's right, because this would be negative 5 over 13, right? This is 2 negatives, so this would be positive. 2 negatives, it would be positive. 2 negatives, it would be positive. So this is one that is not equivalent to it. Any questions on that? Okay. So the next part, we're going to find x and y, and we're going to use it using similar triangles. Okay? So we're going to use similar triangles. Which means no calculator. So step 1 is you want to draw the representative triangle. What I mean is they give you this triangle. So you need to draw a triangle with the same orientation as this one, like this. So you want to look about the same. I mean, it doesn't, you know, you're not going crazy to make it perfectly the same, but about the same. With the measures of the angles the same. And then you want to mark the sides according to the special triangle. So you're going to drop the representative triangle, which is going to be the special triangle. Now, there's 2 different kinds of special triangles, right? We'll go over those as we go. And mark the angles and the sides. So if this is 60 degrees, then this angle right here has to be what? 30. So in our special 30, 60, 90 triangle, across from 30 is what? Do you know? What? Well, if you're going to call that x, then what do you go? What's across from 60? You got to speak up. I can't hear you. Or what's across from the hypotenuse? Special triangles. Did y'all not remember these? Do you remember learning about them? But you've just forgotten it? Okay. There's 2 special triangles. One is called the 30, 60, 90 triangle. And one is the 45, 45, 90 triangle. So these triangles, any triangle that has these angle measurements will be similar to other triangles with these same angle measurements. And they're called the special triangles because we use them for everything. In the 30, 60, 90 triangle, across from 30 you put a 1. Across from 60 you put the square root of 3. And the hypotenuse you put a 2. Now, I'm not saying that the leg on the bottom is a 1 and the leg on the left is a square root of 3. Notice the way that I said it to you. I said the side across from 60 is the square root of 3. The side across from 30 is a 1. And the hypotenuse, which is across from the 90, is a 2. And in the 45, 45, 90 triangle, the sides that are across from 45, of course, you know they're going to be the same, right? They're both 1s. And the hypotenuse is the square root of 2. And you have to memorize this. Okay? So this is my special triangle that I drew with the same orientation. Meaning, I didn't draw it like this because this picture didn't look like this. I drew it with the same orientation as this one. And I marked my angles. Now I'm going to use these numbers to mark my sides. So across from 30 is a 1. So here's my 30-degree angle. The side across from that 30 is a 1. Across from 60 in my special triangle is the square root of 3. The side across from the 60 is the square root of 3. And this one, the hypotenuse is 2. Here's the 90-degree angle. This is going to be the hypotenuse, so I'm going to put a 2 right here. Now remember what I told you, that these special triangles, that they are similar to any other triangle with those same angle measurements. Of course they would be, because any triangle with angle is similar to another one, right? Remember that angle? Yes or no? Okay, so it says that if two triangles have two pairs of corresponding angles that are congruent, then the triangles are similar. So these are congruent to each other. That would be 30 right there, wouldn't it? These are congruent. Well, of course, these are congruent also, right? So with the angle theorem, you can say that these two triangles are similar. And if they're similar, then I can find these values. How? Okay, so what are we doing? We're setting up a what? A proportion, that's right. Okay. So step 1 is to draw the representative special triangle and mark the angles and the sides. I said 3, I said 2. Step 2 is to write a proportion. So in this case, I can say x is to 1 as 9 is to the square root of 3. I could also write another one for y. I could say y is to 2 as 9 is to the square root of 3. Okay, so you're going to write a proportion, 3, and then you're going to solve your proportions. And it may be that you're writing just one proportion. It may be that you're writing multiple proportions. Well, this is already x, right? But I need to rationalize this denominator. So that's going to be 9 times the square root of 3 over 3. So that's going to be 3 times the square root of 3. Any questions on how I did that? Okay. This one I need to cross multiply. So I have the square root of 3 times y equals 9 times 2, which is 18. Then I'm going to divide both sides by the square root of 3. So I have 18 divided by the square root of 3. Then I need to do the same thing to this one that I did up here. I'll multiply it by the square root of 3 over the square root of 3. That gives me 18 times the square root of 3 in the top, 3 in the bottom, and of course that reduces to 6 times the square root of 3. Questions on that one? Anybody? Yes, ma'am.
What is that giving you? Is it giving you X?
It's this gave me X and this one gave me Y. See, the original problem was to find X and Y. Is that what you meant? Well, let's do another one. Maybe whatever it is you're struggling with will make more sense over here. Okay, so we have this big old triangle here. This is X, this whole thing is Y, and that's 10. But it has been divided into two triangles. This is a 90-degree angle. That's 30, so this right here is 60. Right? Okay, if that's 90 right there, then this is 90 right here. And if that's 45, then this has to be 45. Does that make sense to everybody? Zach, you awake? Mm-hmm. So, I'm going to start by finding X, because Y spans both of these, doesn't it? Okay? I'm going to start by finding X, but even before I do that, I'm going to split this up into two different triangles. Okay? So, I'm not drawing my representative special triangle. I'm just redrawing these triangles into two separate ones. So X goes with that. And then this one here, this is 30, and this is 60. And this is 10. Now Y is going to be this dimension plus this one in it, right? So I'm going to assign different variables to each one of those. Okay, so let's just call it like A and B. Then I know that Y is equal to A plus B. Are y'all with me on that? Okay, so let's just see something here. I could find maybe B. Now, I only have variables on this side. I don't know this, right? Over here, I do have variable, but I have a number too. So I'm going to start here with this one. So I'm going to draw a triangle with the same orientation as this and mark it with my special triangle numbers, okay? So I'll do it right here so we can be sort of like one on top of the other as much as we can. Okay, so this is going to be my special triangle. So across from 30 is 1, across from 60 is the square root of 3, and this is 2. So I know that this one and this one are similar. So I can set up a proportion, right? And I could find B, couldn't I? Okay, so let's do that. I can say 10 is to 2 as B is to the square root of 3. So 10 is to 2 as B is to the square root of 3. What is 10 over 2? That's just 5, isn't it? Let's just go ahead and change it to a 5. And then I'm going to just multiply both sides by the square root of 3, and I'll get that B is 5 times the square root of 3. And we'll add that back here. Okay? Now I still don't have anything over here. if I could get this side right here, then I know it's the same as the side right here, isn't it? Right? Because I split it into two. They share this side, don't they? So I'm going to get this side right here, and I'm going to call it, I don't like C's. They sort of look, well, it's CB, okay. We'll just use it anyway. So then I can say C is to 1 as 10 is to 2. You see? Okay? So C is to 1 as 10 is to 2. So C is 5. Does that make sense? So this is 5. But if that side is 5, that's sharing it with this one over here, so this is 5, isn't it? Questions so far? Now I'm going to go to this one. I'm drawing my special triangle at the same orientation as this. This is a 1, 1, square root of 2. And we'll use this triangle and that one, and I'm going to find x. So x is to the square root of 2 as 5 is to 1. See, x is to the square root of 2 as 5 is to 1. So x is to the square root of 2 as 5 is to 1. So that means that x equals 5 times the square root of 2. So this is 5 times the square root of 2. So I can put that back on my triangle. I need to find a so that I can figure out what y is, don't I? Right? So looking back here, a is to 1 as 5 is to 1. So a is to 1 as 5 is to 1. So of course that means that a is 5, right? And of course that makes sense because this would be isosceles. Okay, so I had to find x. So I'm going to circle this because this is one of my answers. And y, which I know is a plus b, y is 5 plus 5 times the square root of 3. And that's my answer on 5. Okay. Guys, these are non-calculator problems. So you're not going to put that in your calculator and write down some equivalence of that. Okay. We have to get really good at these special triangles because it's the basis of trig. And we'll be going into that soon. Okay? So you need to memorize what? Right. And don't memorize them like left and right and up and down, right? It's what it's across from, the angle that it is across from. Because as you can see, you can rotate the picture. So it's not going to be necessarily left or right anymore, is it? You okay? Okay. So what we want to do now is I want you to get out your homework and we're going to check it.